267. Okay, here's our daily look at the calendar. Today, 2 sections were due in terms of homework. Today, we have only 1 section we have to cover, 6.2. It has to do with negative exponents, which we actually saw way back when. Today, we're just going to review those and then go into a little bit more detail with negative exponents. And then the bulk of our period today is reviewing for the test. The test is coming up on Thursday, 2 days from today. And I think I said something like this last class, but it is not too late to change the trajectory that you're on. But if you have a bad exam 3, it's kind of getting to the point where it might be a little bit too late. Like we've got to do something soon if you want to change the trajectory that you're on. So that exam is coming up Thursday. Today we'll do 1 section and review. And again, today's section is not on the exam. The exam stops at 5.3. Questions on the oh, one more thing and then we'll take questions. We're actually really coming down to the end, gang. So we have today is 1 section and a review. Next class is a review and the exam. The class after that, we have only 1 section to cover, and in fact, that's the last section we have for the whole semester, 1 week from today. And then we'll talk about the letters. And then a week from Thursday is this optional makeup or retake of exam 2 or 3. We'll talk more about that later. And then last day of the semester is our review for the final exam, which is coming up on, when are we? Thursday, May 15, right? So 2 weeks from Thursday, this course will be officially done. So we're really near the end. Any questions on the calendar? Okay, then let's jump in on page 267. And we'll go to Annika for the objective. Thank you. Let's take a look at number 1 here. We're trying to do 2 times 3 to the negative 2. So first thing I will refresh your memories about negative exponents. We had a really silly analogy that kind of guided you as to what to do when you saw negative exponents. Anybody remember? Yeah, we wanted to make it positive, but there was some kind of silly thing that we talked about to figure out what it meant to make it positive. Had to do with babies. Yeah, right. Negative exponent, negative baby is unhappy with wherever they are. So if they're up in your arms in the top of the fraction, they want to be on the floor. And if they're on the floor and unhappy, they want to be up in your arms. So negative exponents, we're going to think about babies. And then one other word of advice here. If you see a negative exponent, start by writing a blank fraction. First thing I'm going to do for each of these problems that involve negative exponents is write a blank fraction. So let's give a shot to number 1. 2 times 3 to the negative 2. I see a negative exponent. I know this fraction's coming. So I'm just going to begin with a blank fraction, and we're going to fill in. Okay, that 3 to the negative 2. If it helps you, you can imagine the invisible 1 that we know is underneath everything. So is that baby up in your arms or on the floor? Up in your arms, and that baby's unhappy, wants to be on the floor. So let's put the baby on the floor, which means downstairs. And when you put the baby downstairs, it becomes positive. It was a negative baby before, but now it's happy, it's positive. It is very tempting and very wrong to put the 2 downstairs. The 2 has no exponent on it that we can see, right? There's an invisible 1 on the 2. But exponents are very weak. And they don't have nearly as much reach as a lot of people think they have. So that 2 stays exactly where it is. It is unaffected by that exponent. So what do we do with the 2? On the top. It's exactly where it was, and it's exactly where it stays. Okay? So one real common mistake is to put that 2 downstairs. See a negative exponent and move everything. But you're only moving the thing that the negative exponent is applying to. if I wanted that 2 to be affected by that exponent, what would I have to insert into the original problem as parentheses? This is the only way the exponent has the reach that some people think it has normally. Okay, moving on to number 2. What's the first? What's that? That's the end. Oh, sorry, we should actually do the calculation. 2 over 3 squared is really the same as 2 over 9. That's the answer. Okay, number 2. What's the first thing we should write because we see negative exponents? It's written up there in red. Blank fraction. I really think beginning with a blank fraction just sets the stage, sets the table for you. So let's just take each piece in the order that we see it. The first thing I see is a 2 to the negative 2. Does it want to move? Yes, because it's negative, and so it moves. Where does it move to? Bottom, and it becomes 2 to the positive 2. Okay? I'm going to keep reading across the top. The next thing I see is a 5. Does it want to move? No, so it stays just where it is. 5. Only things that move are the things with negative exponents. Continuing on the top, 4 to the negative 1, downstairs. And it's all multiplication. So anytime you write something new, put a dot. It's all times. And that negative 1 becomes a positive 1. Now we move downstairs. First thing I see is a 3 squared. It stays. So we'll put it right down there, 3 squared. Next thing is a 4 to the negative 2. Goes upstairs and becomes 4 to the positive 2. Good. Okay, so we have accomplished getting rid of all those negative exponents. All the exponents are positive now. So next step is to do some calculating. So let's take care of all these exponents first. Upstairs is really 5 times, that's a 16, right? 4 squared. And then downstairs, 2 squared is 4. 4 to the first is also 4. 3 squared is 9. You have 2 choices, the easy way and the hard way. They'll both get you to the right answer as long as you do everything correctly. The hard way is to actually multiply. 5 times 16, who knows that off the top of their head? It's 80, but you have to do a little bit of work to get there. Downstairs, okay, 4 times 4, that's easy enough. That's 16 times 9. Who knows 16 times 9? It's 144, but it's work. And then finally, we'd have this 80 over 144, which we would still have to do what to? Reduce. But it's far better to reduce now. So let's reduce now. Downstairs, I see 4 times 4, that's 16. I see that same thing upstairs. So the answer is 5/9, which is a whole lot better than going to 80 over 144 and then doing a lot of reducing. Another big piece of advice, these problems are easy now because we're just all doing them in a row, but when you see them in the middle of a test with lots of other stuff, it's really tempting to see a negative exponent and think that that means the answer is going to be negative. So all the time I get stuff like this first one, 2 times 3 to the negative 2 is really the same as negative, and then they'll make it positive 3 squared. That's negative exponents have nothing to do with negative answers, right? Negative exponents is this baby thing, the motion thing. So just make sure you're really clear. Negative exponents mean motion, not negative numbers. Okay, next one, number 3. It's kind of another review thing. 4 to the 0. Any number to the 0, we've defined it to be something. Anybody remember what that something is? Have we defined it? We haven't? Oh, we've never seen 4 to the 0. Okay. Well, let's figure out what it has to be. I'm going to come down here to number 4, and then we'll go back up and finish number 3. So here's what we're going to do. Suppose that I give you the following. X to the 5th divided by x squared. Now I wanted to reduce this. Now the fact is there is a shortcut, something you can do with those powers that will just zip you to the answer, but that is not what I'm after. What I'm trying to do is help us develop intuition. You'll memorize plenty of shortcuts next semester if you take another algebra class. What's my advice here? You see x to the 5th, what can we write? 5 x's. So we'll get rid of 2 both. And we're left with x to the third. And we don't need to write the over 1. Okay, so we've done that before. I said don't memorize a shortcut, but now let's observe the shortcut. What could we have done with the 5 and the 2 to get the answer? Just subtract them, right? 5 minus 2 gives you the 3. It seems reasonable enough. Still not, I don't want you to memorize it, but it sure looks legitimate. Okay, let me give you a different one then. X to the, let's go x to the 6th divided by x to the 6th. Let's just jump right to our shortcut that we're not really going to use during the semester, which says do what to those powers? Subtract them. And so we go x to the 6 minus 6, which is really x to the 0. Now that's a really strange looking thing, but the fact is, what's the value of this fraction? Because the top and bottom are exactly the same. It's 1, right? And so if I'm going to give any kind of meaning to this really strange looking x to the 0, I have to call it 1. And the fact is, it doesn't matter what x is. It could be any number at all, except for 0, but that's not a detail we need to worry about. But any number to the 0 is 1. So let's just put up here in red. Well, I'll just circle it here. Anything to the 0 is 1. That's right. So the previous problem is really saying 3 times 1, which is just 3. Really easy, as long as you understand that anything to the 0 is 1. It's really tempting to call it 0. Any questions on this anything to the 0 business? Okay, let's come here to number 5, last one. What's the first thing I write because I see negative exponents? Blank fraction. Okay, first thing we see is that w to the negative 2. Does that stay or move? Moves. So downstairs as w squared. And now looking downstairs, there was a w cubed. Stay or move? Stay. What symbol do I have to write between these two guys? Times. So all times. Now the reason this one is here is because there was nothing left over on top, and we got to make sure we're clear what to put there. We need to put something. This fraction doesn't exist until there's something upstairs. It's a 1. I'll put an invisible 1 in red there. You guys buy that didn't change anything, right? There was a 1 there the whole time. Okay, so if you have to write something, then you got to put it there. It's a 1. It's not a 0. Oftentimes a mistake that I see is people say, well, I don't know what to put up there, so I'm just not going to put anything, and they'll call it this. But that's not right. I mean, these things both need to go downstairs. So this is our answer, and then we'll finish it by just writing out all the w's. Don't think about a shortcut. W squared is 2 of them. W cubed is 3 more of them. This is really 1 over w to the 5th. That's our answer. Okay, classwork starts on the next page. If you see a negative exponent, begin with a blank fraction. Raise the flag if I can help. But let's just come together for a couple of minutes to look at number 4. Okay, we're going to simplify this complicated expression. This is more complicated than any of the ones before this guy. But m cubed over 7m to the negative 1, the whole thing raised to the negative 2nd power. Okay, here's my recommendation. You have 2 choices here. You can either deal with the stuff inside the parentheses first, and then deal with the exponent last, or you could deal with the fact that that exponent is negative first, and then deal with what's in the parentheses last. And it makes really no difference at all which way you go. So how about we clean up the stuff that's inside here first, because that's simpler. So I'm going to do the inside part first. And it's still going to be raised to the negative 2. And I see a negative exponent, so I start with that blank fraction. The first thing we see is m cubed. Move or stay? Stay. M cubed is still up here. Next thing I see is the 7. Move or stay? 7 stays. Exponents don't have very much reach. They are weak. m to the negative 1, move or stay. That moves upstairs, which means you got to put in a dot for multiplication. So far, so good? Okay, still cleaning up the thing on the inside, which means it's still something to the negative 2 on the outside. I really think this problem is more about just like being organized as opposed to like knowing how to do a lot of math. You just have to kind of follow the steps and be really careful what you've done and what you still have to do. Okay, I'm going to put these m's together. I'm not going to write it all out, but in your head, imagine 3 m's, m, next to each other, and then another m next to that one. 4 all together, so m to the 4th is up here. 7 still down here. Yes? So we've cleaned up what's inside as much as possible. Now we're going to deal with that exponent. First thing I see is it's negative. I don't like that. So let's fix it. That negative, that exponent applies to both of these babies, which means they're both unhappy, which means they both move. So it becomes 7 over m to the 4. But at the same time I do that, what do I need to do to my exponent? It becomes positive, okay? So that's a full-fledged step. Some people could do it in, some people like will get confused and they'll try to square and flip at the same time. I think that's dangerous. So I would encourage you to just take care of the negative in one step. Negative exponent, flip everything, move everything. And then next step, I would say I see something squared, so I'm going to write it twice. 7 over m to the 4 times 7 over m to the 4. Yes? Squared, I write it twice. The whole thing was squared because of the parentheses. Equals. Okay, last step. How do we multiply fractions? Cross or diagonal? Straight across. So 7 squared, 7 times 7 on top, 49. I'm not going to write it all out. I'm also not going to do a shortcut, but I'm just going to envision m, 4 of them right next to each other, and then right next to that, another 4. That's m to the 8th. Do you see how it's, like, you don't have to think about shortcuts. You don't have to think about, am I adding those 4s or am I multiplying those 4s? Just imagine it. So that's our answer there. Okay, so go back to wherever you were, but if you're past number 4, then jump to number 5. At some point, everybody needs to make sure they do number 5. It's an important one.